Hello friends, welcome to a new algorithm of the data science and machine learning. Here we are going to see the random forest classification and regression. Okay, the prerequisite of this algorithm is you need to know the decision tree algorithm first, because this is the extension of the decision tree algorithm used here. Now, trees converted to forest. So there is a relationship between these two. That's why it's required that decision tree algorithm should be known to us first. So let's see. So this algorithm is used for classification and the regression systems. Random forest is a type of supervised machine learning algorithm for ensemble learning. So what exactly the ensemble learning is? Ensemble learning is a type of learning where you join different types of algorithm or same algorithm multiple times to form more powerful prediction model. The random forest algorithm combines multiple algorithm of same type, multiple decision trees resulting in the forest of trees, hence the name is given as random forest. So random forest is a combination of multiple trees. It is used for both regression also and classification also. So whatever the trees performs exactly in the same way trees are created here, but the trees are multiple. Now how will it exactly perform these operations? Now first of all, it picks n random records from the data set. Okay, so data set is given to you to train the algorithm. From that, n random records are chosen. Then it builds a decision tree based on these n records. Okay, so it means that if n records are chosen, that number of trees are generated. Choose the number of trees you want in your algorithm and repeat step 1 and 2. So whatever algorithm you require, whatever trees you require, that number of trees we need to specify inside the algorithm. So trees are created like I need 10 trees, 20 trees, 30, 40. Based on that, the trees are generated, and then we are going to perform operations of predictions. So in case of regression problem, for a new record, each tree in the forest predicts the output y. Okay, and the final output can be calculated by taking the average of all the values predicted by the trees of the forest. Average is generated with the help of regression problem for the regression problems. Or in case of classification problem, each tree in the forest predicts the category to which the new record belongs. Finally, a new record is assigned to the category that wins the majority vote. Okay, so exactly how it is done. Let's see graphically. See the majority voting concepts here. For example, I am having a data set X. Now this data set is splitted in the form of n1 first data, n2 second, n3 third, n4 features. 4 parts I have created, and so it means that number of trees expected from the random forest are 4 here. Okay, so 4 trees are created. Maybe their structures are different, it is shown same, and after that, once the trees are formed, when new data set come for the prediction, the new entry come for the prediction, what will happen in that case? So that entry will go here and will be passed to every algorithm for prediction. So for example, in first case will go in this direction, it will find class C. In second case, it will go to in this direction, will class D. It will go in this direction in class B, and for third it will go in this direction in class C. Okay, so first tree as identified as class C, second tree defining is D, third tree is B, and the last tree is C. So you just can identify that two trees have given the output C. It means that the prediction of this data will go to class number C. That's what we call as majority voting, and final class will be decided. So not the single tree, but n number of trees are created, and with the help of that trees, the prediction of the output is done. Now if you go to regressor's output, now check it out. Again, n number of trees. For example, in the given trees, I have given n is equal to 600. That is, number of trees are 600. Any number of such trees are possible. Make sure that. So tree 1, tree 2, and till tree 600. And when you are going to do the sample, when you are going to do operations of finding the regressor, so for example, in first tree it will go in this direction to find the prediction. Second tree in this direction, find the prediction, and go on. 600 tree will go in this direction, find the predictions, and after that the final output will be generated by averaging all together. So they will get averaged, and then random forest will do the prediction of regressor's output. Okay, so this is how random forest regression operations will be performed. Okay, so this is how a simple algorithm is there. If you are going to see the advantages of using the random forest, it is not biased since there are multiple trees, each tree trained on the subset of data. Basically, the random forest algorithm relies on the power of the crowd. That's what we call as majority voting, on what the democracy relies. Here also, a classification system of random forest also relies on the democratic systems like majority vote. This algorithm is stable. Even if a new data point is introduced in the data set, overall algorithm is not affected much, since new data may impact one tree, but it is very hard for it to impact all the trees, because only one tree will be affected. Okay, that's one main advantage that we can consider here. The random forest algorithm works well when you have both categorical and numerical features. Just like decision tree, advantage is there for random forest also. It also works well when the data has missing values or not being scaled well. Okay, major advantage. Most of the algorithms are required feature scaling or normalization, but decision tree and random forest algorithm don't require these particular concepts. Okay. Now, what are disadvantages? So, major disadvantage of random forest lies in their complexities. They require much more computational resources owing to the large number of decision trees joined together. If you consider, I want to generate a single tree, I require 1 second. If I require 100 trees, I require 100 seconds. Okay, so that's what the disadvantage main it contains. Due to their complexity, they require much more time to train than other comparable algorithms. Okay, so these are the prime disadvantages that we need to have. Most of the time, random forest can provide more accuracy than the decision tree also. But the problem is that we need to sacrifice the time. So we'll see all these things practically implemented with the help of our algorithm. And to simplify this, I'm going to use the same data set which I have used for the decision tree algorithm also. Okay, so let's continue with our practical applications. Okay, so I'll just close this and now open our data set first. So our data sets meaning that I'll revise it again. So some nodes, bank nodes, fake and not fake nodes I have identified. Fake and not fake nodes. Let's check it out. See, so when these nodes are scanned, their image properties are saved in this data set, like variance, skewness, kurtosis, entropy, and then based on that the class is decided. So first few nodes are fake nodes which are 0, and after that we are having the original authentic nodes which are 1. There is no relationship can be found easily here, but with the help of the tree we have formed the relationship. In last algorithm we got almost 97.95% accuracy. And now let's continue with the same data set where in the random forest also, and we'll identify what can be the accuracy we can achieve with the help of random forest classification system here. So I'll carry forward the same data set for this algorithm. So let's go using this. Yes. So here I'm going to show 3 different programs. The first program will go to random forest classifier, second program will go for random forest regressor, and third program is therefore comparison of performance between the random forest and the decision tree algorithms here. Okay, so let's continue. I'm importing my data set first, importing my packages, and after that I'm going to read my data set, whose name is banknotes.csv. I'm reading it, and let's check the shape of this data set. You can easily find it. 1372 number of rows are present. That number of nodes were scanned to create this data set, and 5 number of columns are present there. Now what are the column names? Variance, skewness, kurtosis, entropy, and class. So out of this I want to store the exactly first 4 entries, means all the rows, and the column number 0 to 3 means 0, 1, 2 and 3 inside the X. Okay, so even we can use drop function also, drop method also, but I'm using this 4, and the variable class, that is output variable, I am storing in Y. Let's see the head, means the first few entries, so it is correct. These are the 4 input variables. Based on that, trees will be formed, and after that random forest will be generated. Okay, now see how many classes are there in that particular data set. So that we have seen output variable is y, so np.unique function will return how many unique or distinct values are present inside the y variable. So from numpy I am using this, so unique values are 0 and 1, so only 2 classes are present. We have to make sure that how many classes are there, 2 classes can be found with the help of the unique function. Even we can convert this y into set format also, so that how many unique values are present, that can be identified easily. So now data set creation, separation in input output variable is done. Now let's split our data in the form of train, test, split. Okay, so to do this one, I'm going to use this from sklearn.model selection import train, test, split. Okay, so let's try that one. So I'll just make it more clear here. X train, X test, Y train, Y test is equal to train, test, split. Okay, so train, test, split will split your data into 4 different parts that we have already seen. X and Y are the input to this. Random state is 0, and by default it transforms the data set in 75% to training data, 25% to testing data. Okay, and X and Y are already separated. So let's see this random state. Why I am using it? Because the seed point for randomization will be same. If you change it, your randomization in your case will be different, in my case will be different. So I am keeping random state same, so your randomization will be same and my also will be. Okay, so let's continue. So once the splitting is done, so let's split this. Okay, and after splitting is completed, I'm going to have the out of 1372 entries, 1029 entries are going to train data set, and 343 will go to test data set. Okay, that's how easily done. Okay, so and most important thing is that they are randomized. We have seen this already in last program also. X train, if you see the head of X train, so we're going to have that randomized entries. Let's try it one more time. I'll just add one more cell here. Sorry, it's yeah. Okay, so let's try that X train. Okay, X underscore train. Okay, so we'll be having this. Let's check first 5 entries and check their sequence here. So sequence 662 number of numbers entry is first, then 512, then 1193, then 682, then 1313. Okay, so in this way this is randomized. Remaining other things are also randomized. X and Y are collectively randomized in the same numbers. Okay, in the same sequence. Fine. Now after that, we are going to use the random forest classifier. So inside the ensemble package of sklearn.ensemble, I am having random forest classifier class. So from that package, I am reading this random forest classifier class here. So read. Okay, now while creating the object of this, so classifier is the object of it, random forest classifier is the class. And now how many trees you want to create? So for example, I am giving number of estimators. N underscore estimators is the parameter which expects how many number of trees you want to create inside it. That is n estimators equal to 10. Random state is equal to 0. So here also choosing the random records in the trees will be same. So the tree that is created will be same for all those who choose random state 0, here in this case of random forest classifier object. Okay, now let's continue. Yes, it's created. Okay, so I'm using time here. I'll show it later words. Let's continue first with the fitting the data set. Yes, classifier dot fit X train, Y train. So X was the input, 1029 entries will go here. Y train, okay, its output, corresponding output is present there, and the object is formed. Okay, so object is created. For classifier, you can see the parameter which are by default provided over here. These are the parameters. For default values are requested. Out of these 2 values I have changed by myself. These values were number of estimators Okay, they are 20, 10 I have given here, and random state 0 is provided. Remaining other values I have taken as it is by my own. Okay, so let's continue. Okay, so object is created. Now I'm going to provide remaining 343 entries as input to this algorithm to identify that whether predicted output are exactly equal to the original outputs or not. So let's run this. Ypred is equal to classifier dot predict x test. So I'll get ypred. Now I want to compare. I have to compare the ypred and ytest so that the output can be easily checked. So to compare that, I am going to read this data, sklearn.matrix, import confusion matrix first, okay, so that we have seen, accuracy score, then classification report. Okay, so these three functions I am going to read from the matrix. Okay, and now print the confusion matrix. Let's see the confusion matrix for this case. Yes, now this is the confusion matrix. From this direction we have predicted class, and from this direction we have actual class. In actual data set, 195 entries will belongs to the class number 0. Okay, out of 195, 193 entries are matching. Yes, and 148 entries will belongs to class number 1. Out of it, 148 all entries are matching. Here only we have 2 misclassifications. Yes, if you compare the same thing with the previous algorithm, that is decision tree, there we having 7 misclassifications. Now for this case I am having only 2 misclassifications, and if you are going to see the accuracy score of this algorithm here is 99.41. how it is calculated? So 341 means total entries that were matched. Okay, so 99.41, again same, this is what the formula that they have used to find the accuracy score. In case of decision tree, 97.95%, here in case of random forest, 99.41. so almost 1.5% accuracy improvement we achieved in the random forest classifier. Okay, now let's continue with a few more applications which are possible in the decision tree algorithms also. Now we'll plot this. The whole structure of the trees are not possible. Individual tree we can plot, and we can find their tree structure also over here. Before that, let's see few more concepts. Now there is in classifier object there is a attribute called as feature underscore importances. This feature importances signifies which particular feature as is used for which how many number of times. Okay, so what's importance, that means how impact is there for this particular feature in the final output. That's what is important. See, the thing is that you can easily identify that whether this particular feature or input variable is used inside the generation of final tree or not. Okay, I am multiplying it by 100 because these are shown from 0 to 1 format only. So if I multiply that, you can just check it out. So the output generated here, what's the significance of this? Variance is having 59.82% impact in the output. Okay, then skewness, second parameter, is having 20.91% impact in the output. Next, that is kurtosis, I think 14.96% impact in the output, and entropy is having 4.29% impact in the output. So you can see variance is having highest impact in the output. It means that when we are predicting the fake node and not fake node, we are having variance is the main parameter is having highest impact to classify the node fake or the authentic. Okay, and if you are going to plot this, so for plotting I am using a bar plot over here. This bar plot will show you the feature importance as per the bar. So I am importing the matplotlib.pyplot as plt. X label, on x side I am giving a feature name, y side I am giving importance of it, and then bar, x side again columns. Okay, all the column names will be provided here, and on y side the feature importances, okay, into 100. So in case of percentage will be given. Make sure that I am given this in comment, applicable to the decision tree also. So in case of decision tree also we can use this, which feature having how much importance you can find. Check out the graph again. Variance is having almost 60% impact in the output, then skewness, then kurtosis, and then the entropy. So it may be found in some cases that one particular feature or multiple features are not used in generation of the tree finally. That may also happen. It means that they are not having any information gain within that. That's why they are skipped. Okay, and same method I'm going to follow here for generation of the trees, but one thing you need to remember here is that this is not tree, it is forest. At a time only one tree is possible. So from externals 6 I'm importing string IO object, then ipython.display I'm using image object, and tree I'm exporting graphies. As I have told already, in decision tree also we need to install the packages like ipython, py.plus and graphies. Okay, so these three packages are required, and from operating system also we have to install the graphies package. It depends upon the operating system's compatibility whether this package will work or not. So you just can try by your own. Now create the data object like string ios object, and finally I'm going to use the export graphies. So here, apart from the decision tree, so some changes are made. So one important thing you have to remember, that in classifier object, okay, all the trees separately present in the form of collection of objects, and they are stored in the variable called as estimators underscore. Estimators underscore is a parameter which stores the list of all the classes, list of all the trees, okay, generated from it. So I have generated 10 trees over here. The 10 trees are stored inside the classifier.estimators. Okay, so let's use this one. I'll just add one more cell here, and let's fix it. Classifier.estimators. So the estimators. See, all of the decision tree object will be printed. So see, 10 decision tree objects are there. How exactly these trees are used and trees are generated, that we can find by this. Okay, classifier.estimators. So I'll write a semicolon here, so output can be suppressed. Okay, create the data object, and now I'm going to show only single tree, first tree out of all the 10 trees. That's why I'm using classifier.estimators 0. So first tree will be formed. Out file is .data, field equal to true, means the particular square rectangle will be filled with the color, rounded rectangle will be there, present true. Now this applicable decision tree also. Feature names, last time we have seen the names of the features, just they are termed as x0, x1, x2. I don't require that. I want exactly name of the feature instead of that. So if you want to use it, feature underscore names equal to x dot column. So whatever column names are present, variance, skewness, kurtosis, entropy, that will also appear on the tree. Okay, that's what I am given there. Special characters true, subscripts, and what class names, even class name is also given. Which class is having highest impact on that node, that will be shown. So class names are 0 class name is fake, and class name 1 is authentic. So that will also be shown on which particular class the node is classifying. That we can find by applying this data, that is class name equal to fake and authentic. Okay, so let's build it. So decision tree random forest is created. If you go below, graph dot, okay, py.plus dot graph from data get value. So get this value by graphies, okay, graph, and after that write underscore png tree.png. So the first tree is generated here. The first tree generated. I'll go here. Yes, let's see the first tree which is in my current working directory. Okay, this is the first tree. Check it out. So if you go in detail, so you can see this variance is less than 0.59. so this is the Guinea index for it. Samples are 635. Out of that 541 max number of samples are in fake and in authentic. Okay, so if this condition is true, we'll go in this direction. Then skewness is used, and in this direction also skewness is used. So skewness here is 6.8, and here we are using 4.9. And then go ahead. If you are going this direction, kurtosis, variance again, and then Guinea is 0. So value is 36. All nodes are fake here in this class. Here all the 2 nodes are authentic in this way. Okay, so this is how a single tree generation is possible. Okay, single tree is there. The class tree number 0 which I have shown over here. Now I want to show all the trees. So if I want to see all the trees, that also we can see. So what's the method? Let's make use of a for loop. With the help of that, all trees can be easily visible there. So let's see how to do this one. Check this. So what I've done, for n in range 10, so 0 to 9, the loop will go. Dot data, and just whatever I've done above, I just added that in the for loop. Export graph is all the names. Okay, but here I'm using estimator number n, so it will start from 0, 1, 2, 3, 4, 5 till number 9. Okay, and after that I'm using this graph dot data, graph from dot data, get value, graph is generated, then graph dot write png, and here I made some modifications. What the png file name I'm giving? Tree plus string of n, means whatever is containing tree 0, tree 1, tree 2, tree 3 dot png. So this file will be generated. Every time file will be different because n is changing from 0, 1, 2, 3, 5, 4, 6 like all till 9. Okay, so every time the next classifier, next estimator will come n, and with that number tree is saved, then 0, then 1, 2, 3, 4, 5 onwards will be going on. So we'll take some time. Let's see how trees are generated here. I'll go to my current working directory. Yes, you can check it out. The trees are started. Tree 0, tree 1, tree 2, tree 3, yes, tree 4, okay, tree 5, then tree 6, 7, 8, 9. Okay, so they generated, maybe yes, operations are completed. You can check it out. And if I just check these trees here, okay, we'll go, yes, see, this is the first tree, sorry, this is first tree, tree 0, second tree, next tree, third tree. Yes, if you see the tree structure, almost everywhere is different. See, now this tree is different. Every tree generated separately based on the subset of the data set. See, here in samples, 644 samples are used in generation of the trees. Random 644 samples are there. If I open that, here 636 samples are used. You can check this number, 636 samples are used, okay, in generation of this tree. Okay, let's see a few more trees. Tree number 9, the last tree. Okay, here 629 samples are used for generation of trees. So every tree is different, and when the prediction happens, that time this value will be given to every tree and generating the output, and the majority voting is done. That's why these 10 trees are giving majority voting, and after that, out of 343 test data sets, I am having only 2 misclassifications out of it. It means that its algorithm is effective than the decision tree. But what exactly advantage I am having? Accuracy. But what disadvantage I am having? That also I'll show. Okay, let's go for the next one. The last most important part, single entry predictions. Now, if new node comes with contains these parameters which are mentioned in the list of list. See, this is first variance, second is kurtosis, then entropy, skewness, then kurtosis, and then entropy. Okay, so this new I am creating. See this. And finally, if classifier dot predict new of 0 is equal to 1, then print the authentic node, else it's a fake node. So you can check the output, it's a fake node. Okay, so single entry prediction is done in this way. You can easily find whether the entered node, whether the node which is now scanned from image is fake or not fake. This single entry prediction as similar to the one that we have seen in the previous classification algorithm also, that is recent tree algorithm also. Here also it is possible. So in this way, the random forest classifier will generate the results. Okay, now what I'll do, I'll go to compare this algorithm with the decision tree. So what I've done, let's make a small things here. I'll read this data, let's compare it. I'm going to write both of these programs together. So here I'm taking x, then taking y, splitting. Yes. Now, so let's see the things here. sklearn.ensemble, I'm using random forest classifier and tree decision tree classifier. So both classifiers I am taking together in this particular program, and then I'm going to generate their objects. So random forest classifier estimators I'm keeping. Okay, let's keep the estimators 10. Random state 0, and for classifier underscore dt is decision tree classifier is random state is 0. Okay, so here only single tree is present. Here I am having 10 trees present there. Now Okay, so two comparisons will do. We'll compare with the accuracy also, effectiveness of algorithm plus the time required to train and predict. So to have this time required to train and predict, I am importing a time module from here, and if you write time dot time, it will return the system times in terms of seconds. Okay, and this is time 1. This is recorded before actually the training of decision tree happens. So classifier underscore dt dot fit. Okay, so x train and y train I have given. Then second time, once the fitting is completed, then I am using the second time, time 2. Okay, so the time elapsed between these two, that is required for fitting in decision tree, will be found after this. Okay, so after that I am using classifier underscore rf. So I am going to fit the random forest algorithm on the same data. Then time 3 I am recording. Time 3 is equal to time dot time. So 3 time I am having there, time 1, time 2 and time 3. Now I want to find the time required for training on decision tree. So how it is done? Time 2 minus time 1. Okay, so the time is presented in the form of the milliseconds. So I want this data in the form of the seconds. Sorry, it's presented in the form of the seconds. I want this data to be in milliseconds. So what I am doing? I am multiplying this number by 1000. So it will go in milliseconds, and by using np dot round 2 means after dot I am having only 2 positions present there. Okay, and ms will be attached after that. When I run this, just can check it out. Okay, so what's the error? np is not defined, so I need to import the np also. So import numpy as np. Yes. Now check this one. Training for decision tree is 9.02 milliseconds and training for a random forest is 47.64 milliseconds. So you can find the difference of training time, fitting time required. Every time will be different. Remember, will not get the same output. It completely depends upon your system resources, your RAM, your microprocessor performance. So your output may be different in that case. Okay, but see the difference individually. Decision tree times and random forest times required are different. This is how I am recording a time here. There are few more methods also possible that we'll see in the upcoming sessions, how to record the time. Now after that I am using a prediction time recording. Prediction time, so whatever prediction I am doing here, classifier dt dot predict x test. So I got y pred dt, and classifier rf dot predict x test, I got y pred rf. But here also time 1, then time 2 and time 3 times are recorded, and I am printing the prediction time in the same way. Okay, time 2 minus time 1 into 1000 milliseconds for decision tree, time 3 minus time 2 into 1000. Okay, so 2 points after the dot, and that's milliseconds are. Okay, so let's use this. Let's compare this also. Prediction time for decision tree is 2.34 milliseconds. Prediction time for random forest is 6.69 milliseconds. Okay, which are given by this. This is how we can compare it. So the performance in terms of time is good for decision tree, but if you see or if you compare the accuracy score, in that case we'll have a problem. Okay, so let's go find the accuracies of both of these algorithm and confusion matrix also. So I am reading the confusion matrix, accuracy score, classification report. Let's compare. Yes, now accuracy score for decision tree and random forest. So decision tree 97.95% and random forest 99.41%. So almost we are having 1.5% improvement in the accuracy of random forest. Okay, so misclassifications are less. How? Check this. Decision trees contains the confusion matrix. Here 7 misclassifications are there, and for random forest we have 0 and 2 misclassifications are present here. So we are having 5 less misclassification than the decision tree. So effectiveness depends upon your priorities, whether you require the speedy algorithms or whether you require the most accurate algorithm. Based on that, we have to choose this algorithm for doing the final prediction there. Okay, this is how we can compare the performances of these algorithms together. Okay, now let's go for the second part of the algorithm implementation, that we call it as the regressor systems. For regressor systems also I am going to make use of the random forest regressor on the same data set, that is your petrol consumption. So I'll revise the data set again. What data set we are using here? Data set name is petrol consumption. This data is taken from different 48 states of United States where drivers information is maintained. What's the petrol tax that state is containing? Average income of the respective driver is there. How many miles of paved highways are available in that state. Then population of driver licenses in percentages. And finally, petrol consumption. Petrol consumption is the output variable. So petrol consumption depends upon the first 4 parameters, and as you see, petrol consumption is the continuous value. Petrol consumption is the continuous value. That's why we are going to apply the regression algorithms on it. We have applied the decision tree regression algorithm also, and we have seen the accuracy of decision tree algorithm onto it. Now let's apply the random forest algorithm and we'll compare them. So I'm now going to use decision tree and random forest in combination. I'll show the previous program's output and current program's output so we can compare them easily. Okay, so let's go for implementation. So let's read this pdnp, read the consume csv file and data.shape. I'll revise one more thing. You can download this data set from this website also. Okay, so it's available here, all the data sets. Let's see the shape. 48 rows, 5 columns. What are the columns? Petrol tax, income, highways, population, driver license, petrol consumption. Now x is equal to data.drop, petrol consumption. So petrol consumption I don't require, so remaining 4 are the input variables to me. Okay, so these are the 4 input variables which I contain. So you can see the snapshot of the data set here, and y is equal to petrol consumption. Okay, output variable I am keeping in y. Now let's check. From sklearn.ensemble import random forest regressor. So random forest regressor class I am importing from the ensemble package. Okay, so once it is imported, let's create the random forest regressor. But here one parameter I need to specify. Maybe default parameters are also available. They are available. Default parameter means the number of estimators and the random state. So let's have n estimators. Okay, n underscore estimators equal to 10. For example, I have given this, and the random state I am keeping 0 there. Let's create the object random forest regressor. N estimators 10, random state equal to 0. Regressor object is created. Now let's split the data into train test format. So here I am at test size is equal to 20%, which is by default 25%, because data set is very small. 48 entries are there only, and out of that 20% entries I am keeping in test, and 80% I am keeping in train. So 38 entries will go to train. Okay, so train test split exactly in the same way I am using here. Okay, test size only I have changed to 20%. It was default 25%. Okay, now train, x train, then 10 entries are test. Now let's fit the algorithm. Regressor dot fit x train, y train. Okay, so they are fitted, and if you see the estimators are 10 here, random state is 0, which value I have chosen. I just replace them, remaining others are default. Okay, so algorithm has trained. Now let's go for predictions. So y pred is equal to regressor dot predict x test, result is equal to p dot data frame actual y test and predicted y pred. Let's compare it. Okay, yes, I got the result now. 10 entries in y test, predicted entries are also 10. So actual data set 534 consumption, predicted is 573 is the prediction. Okay, so 410, here we have 537, 577, 595, here 571, 587, 577, 623, like. Okay, so go on using it. Now one distinct difference we can find between decision tree and random forest here. See, here you are getting the entries dot some point is present there, but in case of decision tree we have dot 0 everywhere. Because why? Here we are taking average of multiple. That's why these entries are something like this. Getting it? Okay. And if you want to characterize it, let's make use of the mean absolute error and the mean squared error. So from sklearn.metrics, I'm importing mean absolute error and I'm importing mean squared error. So let's see the mean absolute error. how much error we have. Mean absolute error means general purpose difference, average difference between these two is 49.05, and the square difference, mean squared error. Okay, so this is square of the difference and their addition. Okay, this is what we are having, 3611.301. okay, that's on MSC, that we call as mean squared error. Okay, so mean squared error is this for the given case 4300. And if you are going to see the accuracy, so how I identified the accuracy, actual minus forecast means y test minus y pred divided by y test. Okay, so I'm using nv.abs, absolute value identification. Okay, if the values are negative, it will become positive. To do this one, I'm using it. Okay, and average of all and divided into 100. Okay, so that's what error we are getting. And if you are subtracting from 100, so this is how we can consider it is 90% accurate. Almost values generated by the random forest regressor are close to the original values by 90%. Okay, so see the output now. I'll compare this output with the decision tree. Okay, so I'll keep it as it is. I'll open my decision tree algorithm now. Decision tree is regressor, and let's compare. There also we have done the same operations in decision tree. Yes. Now see this one. In case of first, okay, so let's make them near to each other. That is a decision tree regressor. 534 I got here. Decision tree regressor I got 541, and in random forest I got 573. See this. Okay, if you come back again, here 410 predicted as 498, and here it is 537. Okay, if you go back again, okay, decision tree is generating 571 and 628. So here 571 is go to 587. It's almost close values I am generating out of it. Okay, or if you go to last 580, 566, only 14 differences there in random forest. In decision tree 544, 628, so huge difference is present in that. Okay, and go below. So for this case, mean absolute error for decision tree was 60.08, and mean absolute random forest is 49, I think. Okay, 49.05. see how much difference, total 19 difference is present there. It means that random forest is behaving more accurately than the decision tree, and mean squared error here in random forest is 4300, and here in decision tree we are having 5700. So almost 1000 differences there between the mean squared error also. Okay, that's how. And in case of accuracy, finally, this is what I have done, 100 minus np dot mean. So I got 87% here. They are close output are available, and if you go to random forest regressor, we got 90%. So 3% improvement that we are achieving in case of random forest regressor also. Okay, so this way we are going to perform the predictions of random forest regressor, and in comparison with that we can generate correct output. Okay, now the last step, single entry prediction. So I am going to have these 4 values again as input to the algorithm. First value 5.8, 8865, 1986 and 0.51. Okay, so they are generated, they are stored in this variable, and then regressor dot predict new. Okay, 0 because output generated is in always in the array format, so out of that only 0th value I am taking out of it. Okay, that's what, which is that 465.0, which generated here in decision tree regressor was 414, and here we got 465. Okay, so as we consider it is 90% closer value generated by the random forest regressor, we can consider that it is more effective, but again we need to sacrifice the time in generation of multiple trees. For this random forest regressor also, or decision tree regressor also, we can generate the plots, we can generate the graphs. So this can try by your own and try to practice this, try to identify the difference, try to identify the performance metrics for the regressor classification or random forest and decision tree algorithms here. Okay, so okay, this is the last point. If you have any doubts, you can ask. Thank you. Thanks a lot.